So thanks everybody. It's the last workshop of the day. I'm sure you're feeling as spent as we are. So let's get the show on the road and go through the design workshop. So my name is Karine Simard. I'm Director of Marketing for Robotic. You've heard a lot from me this morning. I have Tyler and Louis that are with me today for this workshop.
Yeah, I'm Tyler Behrman, one of the integration coaches at Robotiq. You haven't heard from me much today, so for those who don't know me, I help do technical trainings with partners and also help end users get their applications up and running.
Hello, my name is Louis Bergeron. I'm also an integration coach here at Robotic. I've just joined the company at the beginning of this year, and previously to that, I was a system integrator. And I did it for a couple of years. To give you an idea, my first project, the technical drawing were put on Blueprint, the paper one.
Not this one.
Remember that. So, I've just joined the company to help you on your project, on the integration aspect, and also do as Tyler did, the technical training for the robotic product.
All right. So you heard all about lean robotics this morning. You've probably heard about it during the workshops that you saw earlier this afternoon. So let's step back and just think about why lean robotics matter and why did we put this together. It's really to make products, so to get cells into production faster so that they can scale, so that we can get more done and become more productive, more efficient. So that's what lean robotics is for. And this workshop will look at the design stage for the lean robotics methodology. Now, the design stage is a more methodology intensive stage. Integration and operation are more action driven. So we'll go through these different steps together in the workshop. But before we get started, have you ever heard this question? A few of you, yes? So let's see if you have an idea of having a conversation that sounds like we're going to role play here.
Okay, let's start. I will play the role as the end customer. And I have a machine that I would like to replace my operator with a robot. So I just met Tyler, my distributor, and just said, hey, Tyler, can I put a robot there?
What do you want to put a robot for?
Want to put the robot for?
Yeah.
To replace actually my operator just in front of the machines.
Oh, okay, so for just machine tending, yeah, you can probably put a robot there. I've done it a few times, so I'm pretty confident it'll work.
Great.
And so I'll head back to my office, design some jigs for the part presentation, and of arm tooling to be able to take the part and place it into the CNC machine. And I'll get back to you in about a week's time to give you some news about the application. Great. So I work on the proof of concept. It works fine, so I call Louis, and I'll give him the price. So let's say for this application, it's going to be $75,000 for the robot installed and working. What do you think about that?
$75,000? Great deal.
Okay.
Here's the check.
Pretty good bargain. So I'm now paid. All right. So that was pretty easy. A little exaggeration, but now I'm paid. Perfect. So now I'm going to buy the components. And I'm going to go to Louis, and we'll start installing the robotic cell. But there's a problem.
So, by the way, Tyler, I'm not sure we have talked about that, but our parts are in the box and wrapped in the plastic. Is there a problem with that?
Yeah, there might be a slight problem because the robot's not that good at opening boxes. So I'll have to go back to my office and figure out a way of getting around this little blocker. I also noticed that the lighting is just a little different than when I visited you the first time. So what's going on with that?
Yeah, we mainly use standard windows to take all those great lighting. So yes, the lighting can vary. Is there a problem?
Yeah, that's great. Environmental guy, okay. But what about at night? So it's just going to be dark in here?
A little bit darker, yeah.
All right. Well, I'll have to go back to my office and work on lighting, and I'll get back to you in about a week then about that.
Okay.
So why didn't I notice this the first time I visited Louis? How is this changing? And why didn't I notice any of these things? So now I have to redesign the tooling for his boxes, and I have to redesign the lighting for the camera that's not going to work in the dark. And now we get a phone call from Louis.
Hey, Tyler, I just got an idea. I just think about it, and I think the robots will be probably most of his time just waiting about the machines. So just why not putting in just a little assembly task to the robots?
Yeah, just one small assembly task.
Yeah.
Yeah, why not? Yeah, we can do one small assembly task. So now we have to readapt the tooling, make more jigs for the assembly. And then Louis calls again and again and again. And so now I'm wondering, how did we drift so far from the initial application, and why are there so many modifications?
And for me, my robot's still not producing parts.
Yeah, and I'm still not paid.
Oh, you got the check.
That's right, I did get a check. All right.
All right, so does this sound familiar? You ever had a similar situation in your work?
Yes.
Yeah.
Not this far, I hope so.
So as we can see from this little role play Sam discussed this morning, it's not really about the robot itself. It's about everything that's going around the robot. So really the robot cell itself. So the whole thing is where problems happen. And we tend to be very robot focused because, you know, that's the big thing that happens in the cell. But there's a lot of other stuff that we need to think about. And the lean robotics methodology on the design stage brings a way of discovering all of these little things and all of these surprises before we go to integrate, before we go to the production floor, and we have these issues. So the idea is to really start by looking at the manual process, or the process as it is now, and how does it work, and making sure that we understand it really well. And then from there, start building a high-level robotic process and robotic map and layout as well, and compare both manual and robotic. And as you can see, there's an iteration loop here, because this is not a one-way street, right? You have to go through a few times, because as you compare, you might figure things out that you haven't seen before. You might also find things that you can't do with a robot, that you need to change your cell design before it all works together. And once you're done with finalizing your cell, then that's when you go to bill of materials, plans, and all of that stuff.
So as Karen mentioned, it's a lot of information and it's pretty complex. So both the technical aspect is complex and the sales aspect is pretty complex as well. So all these steps, the robot's not working for Louis, and I'm only getting paid here. So what we want to do is kind of accelerate this entire process by using lean robotics. So basically what that means is to centralize the information, make sure all the information is very clear. So establishing a link between me and Louis to make sure that we're both aware of what the robot's going to be doing in the process. And since we're documenting anything, we're going to be minimizing the surprises later on. So really accelerating the design and integrate phases.
Yeah. And really, we discussed lean robotics this morning. We introduced it, and you have the access of fully outsourced, which has its good sides and bad sides, and fully on your own, which has its good sides and bad sides. And lean robotics really proposes a way of doing it on your own, but not alone. And the idea behind this is that we can support the end user, we can support the manufacturer in building their own robotic skills so that they can get that proficiency and they can get to production faster. And the tools that we have to work with that, first is DUF, our community. A few of you are already members on DUF, so you know how it works. It's a great place to get questions and answers. And people really ask cool questions about application debugging and what can and cannot be done. And we have in the room actually one of our star helpers on DUF. Matt Bush is right here. Thank you, Matt, for being so helpful on DUF. It's great to have you. So Tyler and Louis, can you tell us of how DUF has helped you in your work?
Well, Matthew obviously helped me a lot, and I learned a lot from his posts, so thank you for that. Also, by doing applications and posting videos, I had to push myself to learn a bit more about the robot and what we can do with the robot. And I've seen a lot of people get their applications up and running because of DUF, so in that sense, it helps quite a bit.
And sometime we got some question by sent to the support at Robotic that the answer is already there on the community. So basically, sometimes we just bring a link to all those answer and explanation on DUF. So basically, sometimes everything is already there. Just have to search, and you're going to have this information right away.
Yeah. the second part that we have to help, people get moving with their robots is the integration coaches. So Louis and Tyler are with us today, and we also have David. And the job of our integration coaches is really to help remove technical blockers in the cell deployment process. So hopefully we can work with you while you're doing the cell design. We also help you out if you're at integration or operation, but ideally cell design is the best place to do it because it costs nothing for no one to do that. Once you've got equipment on the floor and your production's interrupted, then it's a little bit more expensive to remove technical blockers. The next tool that we have is Blueprints. We've introduced it this morning. So Blueprints is a mobile-first web application that's designed to document your manual process. It's really easy to use, and what's nice about it is it really guides the end user in answering the questions. I'm sure we've all had the situation where we ask the end user 3 questions, we get 1 answer, and then we have to go back, and there's a lot of back and forth. So with Blueprints, we get all of these questions and answers in one place, including all videos and pictures and CAD files and all of that stuff. So it's really a great place to keep all of the information about that robotic cell project, but also to communicate and interact with the end user. So guys, Blueprint's been online for a few weeks now. What's been your experience?
Definitely the back and forth is a lot easier. So previously, having to email someone asking multiple questions. So what do the parts look like? What's the input, the output? What is the cycle time? You ask multiple questions, maybe 4 or 5 questions, and you get an answer for 1. So you have to send another email with the rest of the questions and hope for a few more answers. Whereas with Blueprints, you can just have all the questions are posted directly on Blueprints, and all the answers are in the same place. So it's quite a bit easier for me.
So those are the people and the tools that we have to help with moving our projects forward. And in order to go through this, we figured we'd do something a bit more concrete with you. So we're going to do a use case. So Louis will play our customer today. He's the owner of Acme Inc. So Louis, can you tell us a little bit about your company and your robotic cell project?
Yeah, I will play that role. So I'm the owner of the Acme company. And basically, I'm a large contract manufacturing shops. And we just received a big order. And we missed some capacity on our CNC machines. So we are looking for a solution to increase that capacity on these CNC machines. And basically, we have chosen to put a robot there. And have this robot, we hope, increasing the productivity, reduce the cycle time. We hope to produce on the break. We hope to produce on the lunchtime. And we hope to have some times at the end of the shift to continue the productions. So to get this more capacity we need for that, to answer that big order.
All right. So if we get started with doing the task map and layout for the manual process, the first thing we want to do is map the manual process. So Louis, can you tell us more about this map?
Yeah, the goal here is to, as we said, is to shorten this design phase. So the first step is to get all this information regarding the actual process. So basically, the goal is to get all the information that we call with the customer. Like in lean manufacturing, the customer, in that case, is the next process. And basically, what is the requirement on this customer is going to be the output of our cell. What's all the information? Probably we need pictures, we need information about the minimum, maximum size and weight. And also we need all the information regarding what's in the inputs. How many numbers of models, the minimum size, minimum weight. And also describe all the actual process which is done manually. And also getting all the, what is the information flow. How comes the work order, for example, to the CNC machine? Is it a paper work order? Is it a barcode? Is it a RFID tag? And what is the information flow inside the process itself? And what is the, I always forget
Key
that.
performance indicators.
Thank you. So basically, if we get everything as fast as possible at the beginning of the process, so we will shorten this design phase. So basically, we have designed these tools to help you just at the first steps and shortest as possible get all those information as soon as possible in the process.
So when doing the manual mapping and figuring out the layout for the manual operation, 3 guidelines or rules to respect or to help get the proper information. So 1, ask the process expert as many questions as possible. So the process expert is a person who knows the ins and outs of the process, knows the inputs, the outputs, and knows what key performance indicators are important for him and what part of the process will add value. Number 2, well, also part of number 1 would be to include the cell operator. So this person might not have as much knowledge about the process as the process expert, but will have a lot of information about certain details or little particularities of the process. So if a certain jig doesn't work correctly, or if he has to wash certain parts before putting them into the CNC machine, for example, the operator is going to have a lot of information regarding this. Number 2 would be to actually go and visit the cell to get a point of view of the cell, and that way you'll also be able to get a timing of the cell. So that will help quite a bit. Remember to take videos or pictures of the cell, because otherwise if you get in the car, you start driving back to your office and you're listening to music, you might end up forgetting some of these details. So pictures and videos will never, you'll never erase them from your memory. And also ask questions. So asking questions now before the robot has been installed and before all of the buying and the installation has been done. Questions early on don't cost very much money, but questions later on when the robot's installed and then you get surprises, those kind of questions will end up costing quite a bit more money. So don't shy away from asking a lot of questions in the design phase.
Absolutely. So, Louis, do you have a story about this by any chance?
Yeah, I just have a little example of how it could be really important in that phase. In my previous job, we were doing robotic integrations. It's quite a huge system for us. It was a huge system. Roughly, it was $750,000 projects. And the owner of the companies, the end user, said, oops, it's my first robot in the shops, so I would like to keep it secret. I tell him at this point, it's maybe not a good idea. He just would like to have it secret, so we're not allowed to talk to the operators. So I usually always have this operator, the guys, which has a lot of information regarding this particular applications, because you do it not 80, but 40 hours a week, so he really knows all the details. It wasn't possible. The owner would like to have the operator in the design phase. And actually, we did the project. We delivered the cell. And on the first week, just the operator said, I have a special supplier once every 3 weeks that our stuff is just some sand on it, some dirt, and we have to clean with that particular supplier. So we just do, what do you do? What we can do with that? Everything is done, the cell, everything is here, and now we have a big problems. It's really not interesting to have this surprise at that stage. So that's why we highly recommend all have those little details that can fail a project. Not fails, but take you some money and some times.
For sure. So, with what we know of Acme Inc.'s case, what should we ask? What questions should we ask?
So we will play the role together. You will ask me the question about what do you need to know about my project in my shop.
So if you look at the handouts that you have on each of your chairs, you'll have the manual mapping as well, the manual process. So then take a look at those, remember each part of the process, and then you can ask questions regarding that.
So basically you have just one?
What's your budget?
What's your budget? It's a good one. Let's say 90,000.
Cycle time?
What's the cycle
So-
time is here? It's certainly the actual cycle time. Yes, it is. It's a good.
Weight.
It's the weight, exactly.
How are parts presented?
Yes, in the manual process, yes.
So how were the
If-
parts presented?
Yep.
So in your case, how are they presented?
Yeah, right. You're right. Actually, they are presented right stack on top of each other, at the input, and also at the output. The operator just take the parts and just put it on stack on the tables on the input and output side.
How many different parts?
You said
How many different parts?
there's 4 different kind of models we produce on that machines.
How many machines does the operator manage?
You said.
How many different machines does the operator run?
Actually, the operators just manage just one machine. So basically, you probably already know some of the questions you need to have on your projects. But basically, what we have do with our blueprints software is to give you all those kind of questions you may need later on. So on the blueprints, all the questions you may need are already there. We just have to make a fill in the blanks. So it's going to be really easier to have all those information as fast as possible at the beginning of the process. So Karine, can you present this?
Yeah, for sure. So you're able, you have, the process itself, output, input, and additional information, and you can put as much information as you'd like, and you can upload pictures and videos. The nice thing about blueprints is if you're in the blueprint itself with your phone, you can use your phone's camera to take a picture or take a video. So it's very easy to do, either if you're doing a factory visit or if your end user needs to provide that information. So it's very easy for him or her to take that picture right into Blueprint, it uploads, and you're done, instead of having to think about it and take the picture and download it to the computer and put that in an email and all of that stuff. So in terms of process and getting the information, it's good. But in terms of keeping the information in one spot, it's really good because everything is in the Blueprint itself. So instead of being across 5 emails or different hard drives, it's all in one place. And you're able to see, for example, here, we can see the stacked finish part that the end user is provided. So you have besides having just the description that the end user is giving you, you have the actual picture, and it's in the blueprints. So you can go in and ask additional questions. So for example, here, we were wondering if there was, because this is a CNC machine, tending application, if there was any oil or dust or high temperature, which are things that we tend to see in those cells. And Louise answering, it's not, it's a regular shop environment, so there's a little bit of oil during the milling process, and the vise and the part will need to be cleaned. So knowing this, Tyler went up and added this information to the blueprint so that you have a record of this, and you can keep working on mapping your manual process. So that's pretty much how Blueprint works. So you can use it with your own end user. You can use it with us. We can use it with the end user and us and yourself. So it's really a way to work the 3 parties together. And you're able to see the customer's timeline, or if you have yourself a timeline, you've committed to the customer to go into production at a specific date, then you can record that. And it's a good way to have this record of all that information, all that agreement between you and your end user, and it helps you move forward.
Excuse me?
Yeah.
But is it connected, if I have it on my phone and I use it, is it my information and I choose to send it to you, or are we all linked by default?
The person who creates the blueprints,
Yeah, it's on my phone.
yeah, it's on your phone, so you're sending it in Robotics server, right? So
By
Robotic,
default.
by default,
Yes.
Robotic
So
receives them.
That generates a lead then for you and me?
Yeah.
And so can I choose when I want to send it to you, or every time I go out to my customer, you automatically get the information and you're online at the same time as I am?
Okay. Well, there's a question in the blueprint that asks if you already have a local partner that you're working with. So it's a good place to put your company name or your own email. And also, we have your email when you create the blueprint, right? So if we know it comes from you, we know you're on the case. So what you might get is a heads up from us saying, do you need our help with this, or are you on your own and you're good to go? And then, it's your lead and it's protected, right? Does that make sense?
Yeah.
Another question?
If we upload a video or some photographs to Blueprint,
Yep.
who else can see those?
Okay. So the question is, if we upload a file to Blueprint, who else can see it? So as you can see in the URL, it's a tokenized link, right? So it's a long, long link that nobody could remember. It's also SSL encrypted, so nobody can sniff this. It's not indexed by Google. We're keeping out of the servers. So the people who can see this is the people who either created or shared this blueprint. And within Robotiq, it's the sales team and the coaches team that will see these blueprints. That's pretty much it. So as our terms and conditions and our privacy policy applies here, we will not share this data with a third party. The only time where we share end user data with a third party is if we're sending a lead to a partner. So if, for example, somebody in your territory has created a blueprint with us and they're ready to talk to a local partner, then we're going to involve this person with you. Other than that, we're not going to share this information. We don't sell this information, and we're not going to use this information for marketing purposes. Unless you sign a release form for a case study, like we have the case studies on our website, if you sign this, then we'll use the information with your permission. Otherwise, this information is not going to be shared.
It seems like this would violate most non-disclosure policies that we have to sign at our customers.
For me too.
Yeah. So would you send me a picture by email?
Yep.
Well, doesn't that violate the NDA?
No, I wouldn't send it.
I wouldn't send you one either
Yeah.
because we work for a lot of companies, a lot of medical guys, and we've got mutual non-disclosures, all kind of non-disclosures, and me using this, which I love the platform. I just don't like the auto-connect.
Okay.
I have a problem with that fact because
Okay.
here I am, I'm out looking to sell you my product, and I'd like them to do jobs. But automatically, I'm involving you, which I really want to sell your equipment. But now I'm after sending you my customers' information and their product and their setup and all of these things, and it's a
Right.
it's a non-starter
Yeah,
for me. Like
sure.
that I can't see how I could use it, even though I really like everything I've seen until.
Yeah.
It's
Yeah.
like, I'm an auto-connect now, and I'm out of business. I can't do it, and I won't use it, because of this reason.
Yeah.
And I would really like to promote our marketing, and I'd like to do all these things, but I have a couple of problems with it. I can't have, just because I've gone out, I've done 4 sales trips this week, and now I've told you I've done these 4 sales trips, and I really want to sell them, but now I've got you telling me, have you sold it? Have you sold it? I said, look, I'm doing my best. And you said next week, have you sold it? And I said, look, I'll be on when I'm finished. I don't want that. My business is hard enough.
Yeah.
And I really want to sell your stuff. But I can't have that, and I'm not going to have that, so.
All right. Okay. So for sure, this is, if you're under NDA, this will violate your NDA because it shares it with us automatically. I understand this. This is the first version of Blueprints. This thing will evolve over time, so I'm sorry that we're not able to accommodate NDAs right now. But over time, this is a case that we knew about that we're looking to work on. But at present, the system, the servers are on our, they are on our servers. Also, the data is shared with us automatically for sure. Other questions?
We will work on that issue.
Yeah, no, but as I say, I really would like to say I think it's fantastic. I like the whole idea behind it and what you're thinking and how you're doing it. It's just the auto-connect.
Yeah.
So then we're saying, yeah, we have a requirement for this, and we are, as a company, going after machine tending for the next, we've planned,
Yeah.
we've done a number of. And
Yeah. We're working on improving how the sharing is happening. Right now, we have very simple sharing, which obviously doesn't work if you're under NDA. So expect this to evolve, but I can't give you a release date for that, for sure.
But it's a very interesting platform.
Yeah, it's pretty cool.
The concept is fantastic.
We've really enjoyed using it internally for the last few weeks. All right, so we've got that blueprint going. So now we're going to look at the robotic process concept. So is this a full design, Louis, or is this more of a high-level concept here?
Basically, what we do at that step is just a high-level design. We're not actually designing the actual plan, and even this slide here we doesn't like to have you do this nice drawing. Actually, it's just a high-level design. We just talk, brainstorming with each other, and just having a first design just put on place. As we said, we would like to reduce that design time, stage. So basically, it's a high level at that time. At that moment, it's really a high level one.
So this is really what I propose to Louis as the partner. This is really what I'm going to propose to Louis. So I'm showing Louis basically just a layout so he can be familiar with what we're talking about, so we can have a visual base on what we're going to be discussing. So we're keeping the same CNC machine. In this case, I propose a UR robot with two Robotiq grippers and a vision system to be able to locate the parts. So the rest is going to be very similar. And otherwise, we're just adding one table for the machine parts. The next thing I'm going to give to Louis in the proposal is basically the robot program. So this is just a really high-level view of the program. So there's no actual programming involved. It's really just a schematic to show what the planning is, so that Louis is aware of all the parts that are going to be included in the robot process. And so he's not going to have any surprises in the sense that, oh, the robot's not going to be doing this task, or it's not going to be doing this task. We're going to be on the same page regarding the robot process. So in this case, we're using one gripper to pick up the machine part, second gripper to pick up the stock part, and we're using communication between the robot and the CNC machine to start the program and to close the door. So these are just important information so that Louis is aware of what I'm proposing to him.
All right. So do you see a difference between this map and the manual process mapping we talked about earlier?
Yeah, basically it's the same. Once we have designed a rough design of the cells, we goes on the mapping of the robotic process, and basically what we would like to write down is what is the exact same thing. What is the output now? Probably it's the same parts, but maybe they are presented differently. The input could be probably the same, or it can be a little bit different, but basically sometimes the power presentation will be different. And basically also the process will be certainly different, is the goal of that. And probably also the information will change. Basically on the process itself, the information flow will change. And also the indicator could be different. So just by writing down all those points, we will allow us to go from the next steps, which is the comparisons.
So if we, in the handout you had on your chair, on the outside you have the manual and robotic workflow. On the inside you have the cell layouts and the process maps. So if we spot the differences, what do you see that's different between the manual and the robotic process?
Is there a difference?
Less space.
You said less space?
Less space?
Better space utilization.
They are now unstacked rather than stacked.
KPI,
So what's the difference in the KPI?
robots making more parts with the same yield.
Okay, so more parts for the same yield. So remember when you're comparing between the what's that?
Better flow.
Better flow?
Parallel process with the robot.
Okay, so what's the parallel process that's happening with the robot?
You're handling two parts at once.
Okay, so two parts.
All right, so as we start doing this comparison, what we do is what Tyler was guiding us through is looking at each of the 7 parts of the process map and figuring what's different and what's the same. And this really helps us see what adaptations we're going to have to do on the work floor for that robotic cell. So don't kill yourself trying to read that. You're going to get the presentation on rock.robotiq.com so you can read the whole thing through. Maybe after a rest, it's been a long day for everybody. So we go through all of these. Obviously, the process tends to be a lot different. Information flow is one, especially for CNC machine tending, where you have a lot of differences. You have our KPIs and our layouts. So that's how we do the comparison. And as we talked about, this is an iterative process. So as we find something that's different, if we figure out that this is not going to work, then we can update the cell design to reflect what we discover. And as we have this discussion with the end user and the operator, we can also unearth additional hidden parts of the process that we might not have seen. But as they're looking at the process, they can say, oh, but you're missing this part that needs to be cleaned, for example, and then we can add it in our concept.
You have a question?
Well, I'll ask later.
Okay.
And once we get to finalizing the cell concept, then we'll talk about ROI, de-risking the concept, and then we'll freeze our design. So ROI, when do you start calculating ROI? If you're thinking about payback period, for example, what's day 0 of the payback period? When does that happen?
I suppose for the person who orders the job is when they give us a deposit. They spend
Okay.
that money, it has to show
As money leaves their pockets.
I would imagine,
Sure.
yeah.
Okay, all right. So one thing we've seen often in ROI discussions is we tend to start the counter when the cell goes in operation. And that's not the correct way to look at it, because all of the time that we spend in design and integration is part of the project. And so we have to show that to the end user. The other thing that we can see is with the lean robotics methodology, if we're able to squeeze the design and integrate process and make it a lot faster, and that's faster time to production, faster payback, and higher ROI over a year. So those are things to consider when you're discussing ROI with your customer. And now we get to de-risking. So de-risking is about what could go wrong, right, Tyler?
Exactly. So what could go wrong most likely will go wrong. In this case, we're just trying to find all the surprises now while we're designing, instead of finding the surprises when we're on the shop floor and we're trying to run the robot. So any examples are basically just trying to eliminate the risks. So have you guys run into any risks that you didn't think of in the design phase and you got to the shop floor and you figured you had a surprise? Yes.
Yeah, we did a pretty complex cell. Customer sent us hundreds of parts to look at, look them all. They didn't catch it, there's 6 mold cavities that our supplier uses.
Okay.
So depending on the mold cavity, the specific part came out, they all vary some.
Okay.
And so, well, I don't always put the part in.
Yeah.
Because it's not always the same part.
Yeah. All right. Yeah.
All right.
Exactly.
So if we're thinking about Acme's project, sorry, there was a, go ahead.
The fact that cameras don't like oil.
Right. So that would be one of the risks. A way of de-risking the Louis application would be to test his parts with a vision system to make sure that even if it's dark outside and his natural lighting isn't working, that the camera will continue to work. So that would be one risk that we would have to mitigate. Okay, so making sure that the vise opens and closes properly for the machine. So basically getting feedback and establishing communication between the robot and the CNC machine.
What happens if an operator replenishes the stock in the cycle?
Okay.
That's the worst case. What can the operator do during the process? It's hard to know.
Or not do, yeah, exactly. So what happens if the robot doesn't have any parts to put into the machine anymore, for example? So if the operator took a coffee break and forgot to give parts to the machine.
So the idea here is to look at those and to go through what's a pretty standard risk analysis, right? So how important is this to my project? How much trouble am I going to be if that doesn't work? And can I fix it, right? So as we go through the de-risking process, we're able to see, okay, so do I need to eliminate the camera from Louis' design and go with a different type of part presentation if I can't find a way to have reliable lighting? Is there, am I sure that the CNC machine can support IOs? Maybe it's an old CNC machine, right? So how do we focus and to have a plan for going around it? And as you're going through this de-risking, it's basically those small proof of concepts that you're doing. So instead of doing them at the start of the project, so a lot of our conversations, even with end users, they start with, I need a proof of concept. I need to know if I can do this or that with your gripper. And really what we end up doing is having a conversation with them about what they're looking to do and what's their application, what's their parts, and we end up doing a high, maybe more of a high level design discussion instead of doing the proof of concept, because the work that we do too early in the process is not going to be useful often. It's going to be wasted time. So doing the proof of concept at the end of the design phase to eliminate the risks really allows you to not waste time, especially highly technical guys. They're super busy, so if you can avoid having them do work that's going to be useless or wasted, then it's a good, it's a win for everybody.
Exactly. So that gets us to minimum viable robotic cell. So very similar to a minimum viable product. Basically what we're trying to do is get the simplest cell done. So basically it includes all the needs to have, but not all the nice to haves. So basically if we go back to the initial conversation between me and Louis, it would include the robot placing a part into the CNC machine and removing that part. But it doesn't include all the small assembly tasks that he phoned me about. It doesn't include all the other tasks that he kind of wanted through design creep. So basically, if you look at the quote on the screen, it says, "Simplicity is the ultimate sophistication." So basically, if it's Louis' first robotic application, we want a simple application for him to get a good first experience and make sure that it's working. And it's not a process that will take months and months with overly complicated integration. Louis, I think it might have an example or a rule to talk about.
Yeah, we had some customer in the past said, I would like to buy a robot. So I would like the robots to do 100% of the task. And a lot of time doing 100% of that task can cost a really high amount of money and could be really highly difficult. But if we look at sometimes just do 80% of the jobs to the robots and just keep that 20% that will raise the price of the project really high. Just keep that operators to do this fancy stuff that needs some skills to the operators. We're going to be able to have a really more reliable project, less cost, more high productivity, more ROI. So basically, simple is beautiful. It's not because it's a robot, it has to do everything.
For sure. So once we've finished iterating and we've de-risked our project, then we can finalize. That's when we do the CAD drawings, bill of materials, and that's when the quoting and the budget happens. So these are the outputs that we provide to the integrate phase. And at the integration with a properly designed project, then we're able to have way fewer surprises on the shop floor when we're going there to install our equipment. So what's in it for us? What's the point of Lean Robotics cell design?
Well, one of the ideas is basically to figure out the surprises early on instead of later on. So ask questions early on because they're basically free, whereas mistakes due to not asking a question later on could cost quite a bit of money. Number two is gaining control on the project. So by gathering all the information at each step in the process, we'll have a better idea of what the process entails, and we'll also be aware. So Louis and I will be on the same page. We'll have the same information, so we won't have to fight over what we initially established as a robot project. And also we'll have a quicker return on investment as well. So since we're kind of really streamlining the design portion of the process, we'll be getting a quicker deployment, and we're getting a more efficient deployment since we'll have a plan once we get on the shop floor with the robot itself.
So it's a real shortcut of all the design phase that Sam Bouchard as books is talking about. We just cover really fastly all those steps, but in the books it's really well documented and explained all those phases that the ultimate goal is to reduce the length of the design phase, the integration phase. So that's the overall goal of that. We walk through it really fastly, but if you have time to read the books, you're going to have more pictures about all of that.
Yep. So if you want to get the full story on Lean Robotics, everybody's got a copy of the book. It's also available on Amazon right now, and very shortly it's going to be available on Kindle for the paper-free crowd. We also have a website, leanrobotics.org. This is where you'll find a lot of templates and a lot of tools and examples to help you work on your cell designs, on your cell projects, really. And if this is really the first version, so if you see tools that you think we should add, if there's things that would be helpful to you, we do want to hear from you. This is a living project, and we learned a lot from you in the last 9 years building Robotiq, and we want to keep learning together. So whatever you have to contribute is highly valuable to us, and we hope that you will take the time to share it. Questions? Yes?
I agree with you regarding this sharing. It's might be a little challenging. But I also have a question. I really like the idea. I really know what you're talking about. Putting on some music and driving home. From home and all the good plans. Now I'm gonna make some notes. I'm gonna really remember this. And but it's late night and the next day it's all forgotten. So just brilliant.
Thank you.
But the question is this an important part of it? Is a sales to lead collecting tool for you? If I understand.
For us, the objective of Blueprints is to help people get their robots and their cells in production faster. That's really what it's for. And what we found is a lot of people did not have the tools to do that. And we built this tool to help people. So for example, if we get somebody on a blueprint and Robotiq can't help them, so maybe their part's too heavy or it's a suction cup case or it's something like that, we're still going to pass it on to the partner. So whether we sell or not is not what matters.
That was my question actually.
Yeah. So, yeah.
A lot of what we do, we cannot use robotic. But you presented today some new products,
Yep.
software products. That for sure can be included in
Yeah.
those UI or whatever application.
Yeah,
So
for sure.
it's free to use for us
Yes.
instead of
Yeah, so
developing our project.
yeah, so Blueprints is free to use. You can use it with your end users, and or you can use it with us and your end users. And we have end users that come on our website, and they will fill this blueprint. And if it's in your territory, then we'll pass on the project to you. But you can use it only with your end users as well, without our involvement. What we'll do is if you fill out a blueprint and it's your email, we'll recognize that you're a partner. And you'll probably get a heads up from sales saying, do you need help with this? And if you say, we don't need help, we're good, then we'll let you move on with your project.
But it's also included in that kind of a new boss for me now. You kind of don't want to purr on your neck, but I kind of like that as well, because then you will push me.
It can be a motivation, it can be a pain in the neck, it's really how you look at it. Yeah, yeah. Or you can,
It's a sales,
well, obviously it
manager
helps.
for free.
Yeah, for sure it helps get those projects into production, and when a project goes to production, you guys, you make money, right? That's the point. So I think in that way it's good, but the core use of this is to help people get to production. And whether it sells Robotic products or it sells other products, in the end we have more people using robots, and that's what we're looking for. Other questions?
Yeah.
Oh, sorry.
I come at this from a lean manufacturing perspective, because that's what we do as a consulting group. And I'm looking at the steps that you have where you map, the current state, right? And wondering if you would consider, by spinning up your process, by then looking at it in terms of what would be the ideal state, right? The ideal current process that the client would want to see. And then having that would enable you then to determine how can the robotics support that ideal state.
Okay, yeah,
Because
I
think
understand.
there's just
Mhm.
too much back and forth,
Mhm.
so I think you can decrease the amount of time in
Mhm.
which you can get to, because I know eventually you get to it where you reduce the non-value add
Mhm. Yeah.
to the client, but I think, you know, you can compress that by getting from the current state to what ideally, what is it that we want to do? How do we
Mhm.
want this cell to work? And then you can look at how robotics will apply to it.
Yeah.
That, from our perspective, that's how we would, you know, that's how we look at lean manufacturing, from current to how do we really want to do it, and then what do we need to support that?
I think what Sam is pointing in his book is, as the same as the lean manufacturing, is focusing on the customer.
Right.
And in this stage, is just focusing on what is the customer's needs, actually focus on the, probably you're right about the ideal situation, but on the point of the customer of that cell. Maybe, yes, you're right about focusing on the right stuff.
But, you know, lean always looks at what is at most value to the customer.
Yes.
Right, so, but you
If
still
you
look at
if
it
you
from
read the
a-
books, you will see those
Okay.
The same values.
information about values. He more focused on the books with the idea of the customer and the output and on value added. You will see it on the books. As I said, the workshop is really short, but you will see the value added is a really important factors in the lean robotics methodology.
Yeah. The book would be a good way to pass a flight home.
We have a long one, so.
Yeah, exactly.
Yeah, all right. We had another question.
He basically just
You got it?